The story of the digital revolution we know today began with an audacious promise: the creation of a digital currency, decentralized and free from the control of any government or financial institution. This promise materialized as Bitcoin, hailed as Blockchain 1.0. It introduced the world to a distributed and immutable ledger system, capable of validating transactions transparently and securely, thereby eliminating the need for intermediaries like banks. Bitcoin proved that it was possible to create a digital monetary system that belonged to everyone and not to anyone. However, for all its innovation, Bitcoin's technology had a fundamental limitation that would become its main turning point. Its intentionally simple scripting language was restricted almost exclusively to the function of value transfers. In essence, Bitcoin was a high-tech digital calculator, extremely efficient at its task, but incapable of executing any more complex operations. It could tell who sent how much to whom, but it couldn't execute contracts, register ownership, or build decentralized applications. This restriction raised a crucial question that would echo in the minds of many visionaries. What if blockchain technology could be more than just a tool for moving money? What if it could serve as the foundation for creating a new kind of internet, where applications and agreements could be executed without the need for a central authority? The seed of dissatisfaction was planted, and the need for a more versatile, programmable, and powerful platform was becoming evident. The dissatisfaction with Bitcoin's limitations wasn't just felt by observers, but also by a young, visionary programmer named Vitalik Buterin. He was one of the technology's earliest enthusiasts, an editor for Bitcoin magazine, and he quickly realized that blockchain's potential was being underutilized. His mind was buzzing with the idea of a platform that could not only transfer value, but could host any type of programming logic. He believed that blockchain could be the foundation of a decentralized world computer, capable of executing code securely and without the need for an intermediary. Buterin's proposal, initially presented to the Bitcoin community, was audacious: to expand the network's functionality to allow for the development of more complex contracts and decentralized applications. However, the Bitcoin community focused on keeping the network simple and secure for its monetary function, did not embrace the idea. The philosophy of "don't change what works" prevailed. This rejection was the final catalyst that pushed Vitalik to make a radical decision. If the existing network couldn't evolve, he would create a new one. Thus, with a clear vision and a team of co-founders, Vitalik Buterin founded Ethereum. He didn't just want a new cryptocurrency. He wanted a completely new platform, a global computer that would run on the blockchain. Ethereum was designed to be the opposite of Bitcoin in terms of flexibility. Its architecture was conceived from the start to be programmable, allowing any developer to create their own applications, rules, and ecosystems. The seed of Blockchain 2.0 was finally planted, with the intention of expanding the boundaries of what the technology was capable of doing. If Bitcoin was the value calculator of the digital age, Ethereum presented itself as the programmable computer. This is the essence of the conceptual leap that elevated it to the Blockchain 2.0 category. While Bitcoin was limited to recording, monetary transactions, Ethereum was built with the intention of being a decentralized computing platform. Instead of simply transferring funds, it allows developers to create and execute any type of program, application, or protocol directly. On the blockchain, Ethereum is not just a cryptocurrency, although Ether, or ETH, is its native currency, but rather a global distributed infrastructure. This paradigm shift was revolutionary. Think of the difference between a spreadsheet application, which only performs calculations, and a complete operating system like Windows or Mac OS, which allows you to run an infinite number of programs. Ethereum is the operating system of the blockchain. It provides a foundation on which an endless number of decentralized applications, dApps, can be built, operating without the need for a central authority. This open and programmable architecture allows the community to innovate in ways that were impossible with Bitcoin. The true power of Ethereum lies in its ability to turn ideas into digital reality in a secure and transparent way. It opened the doors to a universe of possibilities, ranging from complex and automated financial systems to digital art markets and voting systems. The platform is not limited to a single use case, but serves as an engine for innovation. By moving from a simple tool to a complete platform, Ethereum demonstrated that blockchain could be the foundation of a new era of decentralized applications. The concept of smart contracts is the true engine that enables Ethereum's functionality as a blockchain 2.0. Essentially, a smart contract is a digital agreement with rules coded directly into the blockchain. Unlike a traditional contract, which is enforced by an intermediary like a lawyer or a bank, a smart contract is self-executing and self-enforcing. Once the predefined conditions are met, the contract's clauses are automatically triggered without the need for human intervention. This eliminates the need for trust between parties, as the contract's execution is guaranteed by the code, which is transparent and immutable. The beauty of smart contracts lies in their ability to automate and decentralize complex processes. Consider, for example, a flight insurance policy. A smart contract could be programmed to automatically release payment to the passenger if the flight is delayed by more than 2 hours, based on data from a reliable source. There would be no need to fill out forms, call customer service, or wait for an analyst's approval. The contract, once the condition is met, simply executes the transaction. This not only makes processes more efficient, but also makes them immune to fraud and manipulation. By introducing smart contracts, Ethereum transformed the blockchain from a mere transaction ledger into an automation tool. This functionality allows for the creation of an entire ecosystem of decentralized applications, from autonomous financial markets, DeFi, to games and governance systems. The smart contract is, therefore, the bridge between the ambition of a blockchain 2.0 and its realization, allowing blockchain to be used for much more than just transferring value, but for redefining the way we interact, do business, and build trust in the digital world. For Ethereum to function as a global computer, it needs a system that ensures the network is sustainable and secure. This is where Ether, ETH, and gas come in. Ether is not just the platform's native cryptocurrency. It is the fuel of the ecosystem. Just as you need to pay for electricity to run a computer at home, Developers and users need to pay an Ether to execute any operation on the Ethereum network. This transaction fee isn't arbitrary. It compensates the miners or validators who keep the network secure by validating blocks and ensuring the system runs honestly. The concept of gas is a crucial layer of abstraction that makes the system even fairer and more efficient. Gas is the unit of measurement for computational effort. Every operation on the network, from a simple ETH transfer to the execution of a complex smart contract, consumes a certain amount of gas. The price of gas can fluctuate depending on network demand, but the amount of gas needed for a specific operation is fixed. The user pays a total fee that is the product of the amount of gas consumed by its current price. This creates a system where more complex operations that require more processing power cost more, encouraging optimization and efficiency. This dynamic between Ether and gas is what protects the network against spam and denial of service (DDoS) attacks. If operations on the network were free, an attacker could overload the system with infinite, meaningless transactions, rendering it inoperable. By requiring payment for each operation, Ethereum creates an economic barrier that makes such attacks prohibitively expensive. It's a brilliant piece of economic engineering that ensures the longevity and security of the ecosystem, allowing the platform to continue to be a reliable environment for innovation. What truly allows Ethereum to be a universal computer is the Ethereum Virtual Machine, EVM. Think of the EVM as the engine that runs all the programs and smart contracts on the network. It's a kind of global virtual computer that runs on every node of the Ethereum network. When a developer creates a smart contract, they write it in a programming language like Solidity, which is then compiled into bytecode. It is this bytecode that the EVM understands and executes, ensuring that the same code has the same result everywhere, consistently and securely. This distributed nature of the EVM is what makes it so powerful. Because it operates on thousands of computers around the world, it is uncensorable and nearly impossible to take down. There is no central server that can be shut down or a single point of failure. If a smart contract is deployed on the blockchain, it will continue to function as long as the Ethereum network exists. This is a stark contrast to today's centralized servers, which are susceptible to attacks, censorship, and technical failures. The EVM is therefore the essence of the concept of decentralized computing. It transforms Ethereum from a simple blockchain into a complete development platform, allowing innovation to flourish independently of any central authority. From this virtual machine, countless revolutionary projects have been born, showing that the EVM is the foundation of a new technological paradigm where code execution is transparent, censorship-resistant, and accessible to everyone. The true proof that Ethereum is blockchain 2.0 isn't just in its technology, but in the diversity of innovations it has enabled. The ability to create smart contracts and decentralized applications on the EVM opened the doors to a vibrant digital ecosystem that is now challenging entire industries. One of the most prominent examples is the decentralized finance (DeFi) sector. Built entirely on Ethereum, DeFi recreates traditional financial services like lending, insurance, and exchanges, but in an automated, transparent way and without the need for banks. DeFi showed the world that it's possible to have a financial system that is fairer and more accessible to anyone with an internet connection. In addition to DeFi, Ethereum is the home of non-fungible tokens, NFTs. These unique digital assets, which can represent art, music, game items, and even real estate, are a phenomenon that was only possible thanks to Ethereum's flexibility. Smart contract technology allows the ownership of these tokens to be verified and transferred securely, creating a multi-billion-dollar market that is revolutionizing the creative economy. NFTs have transformed the way we value and interact with digital assets, proving that blockchain can go far beyond money. Finally, Ethereum has also driven the rise of decentralized autonomous organizations, DAOs, and new models for games and applications. DAOs are organizations that operate based on rules coded in smart contracts, eliminating traditional hierarchy and allowing members to vote on proposals. This is redefining corporate and community governance. In games, Ethereum allows for the creation of digital items that truly belong to the players, opening the door to a fairer and more interactive virtual economy. These use cases show that Ethereum is not just a platform. It's fertile ground for innovation that is building the future of the Internet. Ethereum's journey as Blockchain 2.0 is not static. It's a story of continuous evolution. One of the most significant and challenging chapters of this story was the transition to Ethereum 2.0, now known as the merge. Originally, Ethereum, like Bitcoin, operated with a consensus mechanism called proof of work, POW. This system, which requires miners to solve complex mathematical problems to validate transactions, was secure but also extremely inefficient. It consumed a colossal amount of energy, generating a global debate about the environmental impact of blockchain technology. In addition to limiting the network's scalability, the Ethereum community, driven by Buterin's vision of a more efficient and sustainable platform, planned and executed a monumental transition. In 2022, the network migrated its consensus mechanism to proof of stake, POS, a process known as the merge. In POS, transaction validation no longer depends on computing power, but rather on the amount of ETH that validators stake on the network. This eliminated the need for energy-intensive mining, reducing the network's energy consumption by over 99%, a feat that made it one of the greenest blockchain technologies on the market. The transition to POS was much more than a simple technical change. It was a proof of concept that a major blockchain could evolve and adapt to new challenges. This evolution not only solved the energy consumption issue but also laid the foundation for future improvements in scalability and transaction speed. The merge demonstrated the resilience and ambition of the Ethereum community to build a robust and sustainable platform, solidifying its role as a leader in innovation and proving that Blockchain 2.0 is a living and constantly improving technology. Despite all its innovations and the successful transition to proof of stake, Ethereum still faces significant challenges, which are the focus of its future development. The most pressing problem is scalability. With the network's increasing popularity for DeFi, NFTs, and other applications, Ethereum's processing capacity has become overwhelmed, resulting in high transaction fees and prolonged waiting times during peak periods. The merge solved the energy issue and laid the foundation for scalability, but it didn't implement it directly. The need to process millions of transactions per second is the next major hurdle to overcome for Ethereum to become the infrastructure of the global internet. To tackle this challenge, the Ethereum community is focused on two main solutions: sharding and Layer 2 rollups. Sharding is a technique that divides the blockchain into smaller, more manageable pieces called shards, allowing the network to process transactions in parallel rather than in sequence. This will dramatically increase the main network's processing capacity. Simultaneously, Layer 2 rollups, L2, are solutions built on top of Ethereum that process transactions off the main network and then send only a small summary back to the blockchain. This relieves the burden on Ethereum and allows for nearly instantaneous transactions at much lower costs, while still benefiting from the main network security. The future of Ethereum, therefore, is not about a single platform, but about an interconnected ecosystem. With the implementation of sharding and the growth of Layer 2 solutions like Arbitrum and Optimism, Ethereum is transforming into a hive of blockchains that work together to achieve massive scalability. These developments show that the platform is not content with being the current leader. It is constantly reinventing itself to face the challenges of the future and cement its place as the foundation of the decentralized internet. Ethereum's journey from a programmer's dream to a global infrastructure completely redefines the concept of blockchain. Bitcoin laid the foundation, proving that a decentralized digital currency was possible. However, Ethereum took a bold step, transforming blockchain from a simple value transfer technology into a programmable distributed computing platform. It was this paradigm shift that earned it the title of Blockchain 2.0. It is not just a cryptocurrency, but the foundation for a new kind of internet, where applications and agreements can be executed without the need for a central authority. Ethereum's legacy is the demonstration that blockchain technology is an engine for innovation. With the introduction of smart contracts and the Ethereum Virtual Machine, EVEM, it enabled the creation of a vibrant ecosystem of decentralized finance, DeFi, non-fungible tokens, NFTs, and decentralized autonomous organizations, DAOs. It proved that blockchain can automate processes, democratize access to financial services, and create new forms of digital art and governance, all in a transparent and censorship-resistant manner. Ultimately, Ethereum represents the evolution of the very idea of decentralization. It has shown us that blockchain can be much more than just a digital ledger. By overcoming technical challenges and evolving with the transition to proof of stake, Ethereum has solidified its role as the platform that is building the foundations of a more open and accessible digital future for all. Its legacy is living proof that the digital revolution is just beginning, and that the potential of blockchain is still being unlocked, one decentralized application at a time.